Physics C with Mel, Caesar, and Timothy.
Hello, and welcome to another edition of Online Physics. Today we'll be looking at a question from Chapter 11, exercise question number 80. A spaceship of mass 2 times 10 to the 6th kilograms is cruising at a speed of 5 times 10 to the 6th meters per second when the antimatter reaction fails, blowing the ship into 3 pieces. One section, having a mass of 5 times 10 to the 5th kilograms, is blown straight backwards with a speed of 2 times 10 to the 6th meters per second. A second piece, with 8 times 10 to the 5th kilograms mass, continues forward at 1 times 10 to the 6th meters per second. What is the direction and speed of the third piece?
Thank you, Caesar. This is Tim taking over. Mel is currently working her shift at Domenico, so she can't be here with us tonight. So to solve this problem, we're gonna first look at the problem from an external reference point, and let's go over our givens. So we have the total mass of the system or the spaceship before it blew up, and we have the initial velocity. It's positive, so let's assume that forward is positive in this question. We have the mass of the first piece and the velocity of the first piece after the explosion, denoted by the prime. It's negative because in the question it says it is blown straight backwards. We have the mass of the second piece and the velocity of it after the explosion. And for the mass of the third, so we're not given the mass of the third piece. So to solve for that, we take the initial mass and we subtract the masses of the first piece and second piece. So after we solve that out, we're going to get 7 times 10 to the 5th kilograms. And the velocity of the third piece after the explosion is unknown, so that's what we're solving for. So we're going to start by setting up a simple conservation of momentum equation here. So we have the mass of the initial mass of the system times the initial velocity of the system is equal to the masses and velocities of each piece after the explosion. So m naught v naught is equal to m1 v1 prime plus m2 v2 prime plus m3 v3 prime. Next, so since we want to solve for v3 prime, we're gonna isolate it by subtracting m1 v1 and m2 v2 and dividing by m3. So now that we have it isolated, we can simply plug in the values that we have in our givens, and the numerator is going to simplify out to 1.02 times 10 to the 13th, and divided by mass 3, which is 7 times 10 to the 5th, we're going to get the velocity of the third piece. Very simple solution, but now I'm going to hand it over to Caesar. We're going to solve it a second way.
Okay, so for the solution method 2, we're going to be looking for an internal reference point. This question will be set up in almost the same way as the first method, except that for the velocity of each piece is going to be different. The initial velocity is going to be 0, because if we're using an internal reference point, it's almost as if the ship is not moving relative to your reference point. And for each of the velocities after it explodes, you have to subtract the velocity that the spaceship was going at. Alright, so using the mass and initial velocity of 0, we can set the left-hand side of the equation to 0, and have the new values and masses, same masses for the rest of the equation. We can solve for v3 prime using the variables, and then we could just plug in the numbers, and then we get our v3 prime, which is 9.6 times 10 to the 6th meters per second. And what you have to do from that point is add the original speed of the spaceship, which is 5 times 10 to the 6th meters per second, and you get the answer of 1.5 times 10 to the 7th meters per second, which is the same as from the first method.
So using both solution methods, either from an external reference point or an internal reference point, we are able to see that both ways result in the same answer, 1.5 times 10 to the 7th meters per second. Thank you for tuning in. Don't forget to raise our averages and smash that A+ button.
Have a nice day.
Have a nice day.